In this example, we're asked to compute the area of the region in the first quadrant bounded by the three curves x equals 0, y equals x squared plus 1, and y equals 3 minus x. So the first thing we want to do to approach this problem is to sketch each of the three curves separately. The first curve is the curve x equals 0, which we've sketched in green here. It's just the y-axis. The second curve is the curve y equals x squared plus 1, which is the parabola which we've drawn in brown here. The third curve is the line y equals 3 minus x, which we've drawn in blue here. So the region that's being enclosed is this region that's shaded in red here. So we're trying to compute this area. Before we can set up the integral, we need to see which interval we need to integrate over. So if we look at the region, we can see that the region is bounded on the left by x equals 0. So the left endpoint is going to be x equals 0. And the right endpoint, and see, ends at this point here. So we need to compute this x value. We see that the right endpoint is the point of intersection of the two curves. So to find the x value, what we do is we set these two equations equal to each other and then solve for x. In the lower left hand corner here, we've solved for the point of intersection here. So we set the two equations equal to each other, move all the terms to one side, factor, and then find the x values. So we actually get two x values because the two curves actually intersect in two different points, but we're only interested in the value x equals 1 because we can clearly see that we're interested in this point and x has to be positive. So the right endpoint is when x equals 1. So the intersection point is actually at the point 1, 2. Now we're ready to set up the integral. So the left endpoint is 0, the right endpoint is 1, the top function is the function 3 minus x, the bottom function is the function x squared plus 1, and so this is our integral. To complete this problem, we'll evaluate this integral here. So first we simplify this expression. Now we'll find the antiderivative of this function. Finally, we evaluate the antiderivative at 1 and 0. So we get minus 1/3 minus 1/2 plus 2. And then when we plug in 0, the whole thing is 0. So computing this, we get 7/6.